Okay, welcome back. This is Chapter 11. Chapter 11 is more about object-oriented programming on page 257. So this is kind of a wrap-up and add some more details that we haven't had before. So let's start off talking about encapsulation again. If you recall, the whole point of encapsulation is to keep the inner workings of whatever it is you're doing separate and safe from causing harm and interference with other pieces of code. Basically, it's the no side effect rule. In other words, I don't want to have my code break somebody else's stuff, and I don't want somebody else's stuff to break my stuff. So to maintain no side effects, the encapsulation piece has to be done correctly, so that the inner workings of mine only happen, affect my stuff. Okay, so I can update my piece without fear of breaking the rest of the application because in theory there's no side effects, right? Good. And I can keep code from being used in a way for which it was not intended. Now I have a name for this. It's called sanity checking. That's just a cool name. It doesn't actually really have a name. It's just input validation. Before you ask, for example, to calculate someone's pay, you might want to check to see if they actually have a pay rate that's been established and the number of hours that they work that have been established. In other words, if you skip the first two steps and go directly to step 3, step 1 would be fill in the number of hours, step 2 would be fill in their pay rate, and then step 3 would be calculate pay. What if you went to calculate pay first? You need some sanity checking. You need to have some way to make sure that the people that are using your code aren't using it in a way you did not intend for it to be used. Okay, good. All right. So this whole concept of input validation is very, very important. Basically what that means is don't ever, and I mean ever, trust the user to provide the right input. That's just, and we're not talking about, necessarily from a security point of view, like you're writing a secure application kind of a thing. No, we're just talking about in general terms. Don't expect the user to do the right thing every single time. For example, let's say you had a form and you were asking them to type in the age, what their age was, okay? There's probably 3 tests that you ought to do. The first test is, did they leave the box blank? That'd be a good test, right? Assuming, of course, that the age is a required field in whatever it is you're doing. So first test is, did they leave it blank? The second one, does it even convert to a number? If they typed in Mary had a little lamb, when it comes time for me to convert that to a number, it's not going to work. So first test, did they leave it blank? The second test, does it even convert? And then the third test is it within the range of expected values? If you're talking about somebody's age and they're applying for, a credit card or something, you wouldn't expect them to have an age of 6, and you wouldn't expect them to have an age of 600. So there's an acceptable range in there. So again, you don't ever just completely trust the user's input. You need to go through input validation. So in this example, I did 3 tests. Is it blank? Does it convert? And is it inside the range? Okay. On page 259, they start talking about access modifiers. So the access modifiers that we have are, public and private. We actually have another one called protected, as you see here. And we are going to talk about that one. But it's a little weird. So when used on a class, all right? So here's my class, and my choices here are just the same. I mean, you could do a public or a private. I guess you could do a protected on a class, but that's pretty unusual. So my question would be, what's the point here? Well, when these access modifiers being used on a class, that means the class is available to anyone to use, okay, if it's public. Or if it's private, it can only be used by somebody else who's already in the system, so to speak. So you could keep people from doing something. Now, you might think, well, I can't think of a reason why you'd want to do that. Well, you could have an inner class. I mean, I'm not necessarily talking about an anonymous class where you put it as a parameter. I'm talking about a real, honest-to-God inner class. An inner class, like, we had one from the previous course where we had an employee collection, and we had an employee sort class, and we just made it private because no one outside of of that environment needs to know how it was sorted. That's just not relevant to them. And just remember now, Java has an unusual thing, is that all public classes have to be in a separate file, which means I could go down here and build me a private class down here. I could, I could go down here and say, private class, whatever, kumquat. And the machine would be happy as a clam. I won't necessarily be able to do that with a, okay, I guess I can't do that. Won't be able to do that if it was a public one, because public ones have to be in a separate line, a separate file rather. Okay. Now when used with field variables, now it's something different. So you need to know what we're talking about. What is and is not a field variable, okay? So if I was to create me a variable here, I don't know, I'm gonna go down here and say int age is equal to 12. Okay, is that a field variable? No. Field variables are those things that happen at this first indentation level. Now, if I go here and say, string name is equal to Bob, is that a field variable? Yes, it is. Okay, do you see the difference? Variables that are created here are field variables. Variables that are created here are called local variables. So all field variables should be annotated. You should never leave them blank like I have done in line 11. If you do that, I'm probably going to start taking points off. Okay, is that clear enough? So I probably should have said private. And by the way, if in doubt, if you're looking at something about, I don't know if I should make this public or private, or make it private. Okay? If it turns out that that's not the case, you can always go back and fix it. But start off with making all field variables private. Okay, so a public field variable is probably a bad idea. And I typically don't write classes that have any public field variables. I just don't do it. So if you see a public field variable, or you see with one that doesn't have an access modifier at all, where like you left it off, that means you're probably going to get points off. Okay. Private means only the people inside this class can see this thing, which is pretty doggone normal. And protected is a special one, and it has to do with inheritance. And we're going to be doing some inheritance examples here in just a few minutes. But let me just explain how it works, because protected means it's only can be seen from inside my class, and then any derived class. Basically, it's me and all of my children. If I inherited something, inherited from this class, then that thing would go with it. In other words, my children can see it, but not people from the outside. Now, having said that, Java doesn't do it the way practically any of the other languages do it. C++ and C# and everyone else, Visual Basic, everybody, when they do protected, people from another class can't see it. But in the Java world, it has what's called package scope. So anything that has the same package can see it, which is not at all what I want. Okay, not at all. So in all of the other programming languages I just mentioned, I use protected. I typically don't use protected in Java just because it has too wide of a scope. The whole point of having something halfway between public and private, right? Well, this is not between public and private. It takes the whole dang barn door and opens it up. So I don't like it, and I don't use it in Java. I use it in all the rest of the languages, but not in Java. Okay. So typically public, private, and protected, and then the default. Okay, the default is leaving it blank, and that means it has package scope. And quite frankly, I don't ever do that. Not ever, 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 ever. So don't you ever do it either. Okay? So every single one of these field variables should have an access modifier, and most likely 99% of the time they're going to be private. Okay, just saying. Okay. So why do I want to keep something private? So I'm going to build me a I tell you what, I'm just going to use the same example we had last time, if that's all right with you guys. So I'm going to go ahead and create me an employee object, okay? So I'm going to go here, and I'm going to say new Java class, and I'm going to type employee, and then I'm going to copy and paste just to speed things up. Okay, so let's go see what in here is public and what in here is private. So I made these things, these constants, public. Actually, they're public, static, and final. And we'll explain what all that means in a moment. But here are my private field variables. There's one for first name, last name, department, hours, and rate. Now, I have a naming convention that I use. It's called PFV, for private field variable. There's a reason for it, and as we get a little longer, and it'll make a little bit more sense. But right now, it's just a naming convention that I use. You are not obligated to do it the way I do it. I'm just saying that's the way I do it. Okay, so why on earth would I not want to provide access to the hours? Okay, let me just make this public. Okay, public. And then I'm going to go back to my main activity here, and I'm going to build me an employee. Employee imp1 is equal to new employee, and I'm gonna go ahead and just put in the stuff I need, like Bob, Smith, and their sales is what their department is. Dang it! If I could type, this would go a lot quicker. So I could just go here and say imp1 dot, and then say PFV hours is equal to minus 40. And there's not a dang thing to stop me from doing that. So let's go ahead. I'm going to go over here and I'm going to do imp1 dot set rate $10 an hour. And then we're going to calculate the pay for this guy. So I'm going to say ET display append imp1's pay is, or pay equals, imp1 calculate pay, and then we'll throw a carriage return in here for good measures, as we usually do. Okay, so let's run this thing and see what it does. Why, my pay is minus $400. Wow. That ain't right, okay? So I need a way to prevent people from doing stupid stuff. So I go back to here and I make this guy private, all right? Now I won't be able to set that because I can't see it. But I can do this. I can say set hours, and if I put a minus 40 in there, and try it one more time. So I hit kadoink. I hit my guy. I bring it up, and now it says pay is 0. Ooh, how'd that happen? How in the world did that happen? We've found and fixed the problem. How did we do that? Let's go look at it says hours must be between 0 and 84. Okay, so this is what input validation is for. Basically, the programmer can't break my class. It's got to be right. The programmer can't break my employee class. Now that I've fixed the input, let's try it one more time. And hooray, their pay is $400, which is kind of what you would expect. Okay, is this making sense? Why did I do this? Why did I make these guys private? Is it because I'm keeping secrets? No, it has nothing to do with secrets. It's that I wanted to have an opportunity to go in here and check to see if you were messing with me or not. Here's where you set the hours. If you're below the minimum hours or greater than the maximum hours, I'm going to spit out an error message and ignore your input. Okay, you guys getting this, huh? All right, we're coming up on the 15-minute mark.